Hi everybody, and welcome back, and welcome to our new section. Okay, so this is going to be a very interesting or challenging part of the course. This is the one involving trig identities. So, an identity is an equation which is true for basically almost all numbers involve all values of the variables of the equation. So in other words, with an identity, you don't actually have to solve an equation. Okay, it's basically true for all possible real numbers where this expression makes sense. So the what we're going to be doing is we're actually going to be proving some identities. But we're going to, let me just review some of the identities we already know. We have what we call the fundamental identity. It says sine squared of theta plus cosine squared of theta is 1. That, of course, is true for any real number theta, or for any angle theta. Okay. Likewise, we also know that 1 plus cotangent squared of theta is equal to secant squared of theta. And tangent squared of theta plus 1 is equal to secant squared of theta. I think that I said this was secant. This is, of course, cosecant squared. Okay. So these are what we call, your book calls, I think, the Pythagorean identities. Okay, because they basically come from either the unit circle, which comes from, the right triangle trigonometry, right triangle geometry. Then we have some other things that are true for all values of theta where these expressions make sense. We already know that tangents can be written as sine theta divided by cosine theta. Obviously, this wouldn't make any sense when the cosine of theta is 0, and for all the other values of theta, this is always true. The cotangent is cosine theta divided by sine theta, and because of this, we also have a cosecant of theta is 1 over sine theta, and the cosecant of theta is 1 over sine theta, and the secant of theta is 1 over cosine theta. The cotangent is 1 over tangent theta, and the tangent is 1 over cotangent theta, okay, because these are reciprocals of each other. Likewise, sine and cosecant are reciprocals of each other, and cosine and secant are reciprocals of each other. So we already knew this, but here we're just writing down all what we know right now. We also know that the sine of minus theta is equal to negative sine theta. We prove that, using unit circle things. We know that, so the sine is an odd function, and cosine of minus theta is cosine theta. That means that the cosine is an even function. We also prove that using a unit circle. And then from this, we can get that the tangent of minus theta is minus tangent theta. And that's not hard to show, right? That we can actually prove this right now, because the tangent of minus theta, this is going to be sine of minus theta over cosine of minus theta. Okay, but then we know that this is minus sine of theta, and this is just cosine of theta. Okay, so this is equal to tangent minus tangent of theta. Okay, and then you can figure out what the other ones are for. You can verify that the cosecant of minus theta is minus cosecant of theta. Secant of minus theta is just secant of theta, and cotangent of minus theta is minus cotangent of theta. Okay, so these are some identities that some can follow very nicely from others. We also proved earlier that the sine of theta plus pi over 2 is cosine of theta. That we looked at the graphs of the cosine and sine function, and they were one graph was a shift of another by pi over 2 units. Okay, so we want to keep this in mind, and we're going to be adding a lot more formulas to this collection later on as we go on. But so what we're going to be doing in this section is we're going to be using these as our tools, and we're going to prove prove some other identities, which are a little more complicated than this. Now, the good news or the bad news about this is there's hardly any geometry involved. It's all algebra. Okay, and algebra is all about knowing how to substitute and using and how to use algebraic manipulation. So that is the thing to keep in mind. And the only thing you want to the only way to learn this is really just go ahead and do it. Let's just look at some of these examples. So let's say look at this first example. If we want to show that the cosecant of theta times cosine of theta is cotangent theta, then what we want to do is we want to show that this equals this. Usually they're a little bit of a guideline. You usually want to start on the side of the equation which is a little more complicated, and then go through some steps and come out of the other side. So how do we do this? Well, the cosecant of theta, cosine of theta. One thing we can do is let's try to write we can always write things in terms of sine and cosine. And the cosecant is 1 over sine theta. Okay. And focus this a little bit. All right. And then this is sine, then we can put this into a single fraction. And this is, in fact, the cotangent of theta. Okay. So this wasn't too bad. We just have to do some substitutions here. But this is how we'd like all our proofs to work. And we start with one side, and then just a nice series of equal signs, and end up with the other side. Let's look at this. 1 plus tangent squared of minus theta is equal to secant squared of theta. So this is a little more complicated. The left-hand side is a little more complicated again. Okay. Now this is of course the same thing as 1 plus tangent of minus theta squared. That's just how the notation works. And we know that this is going to be minus tangent of theta. From what we had before. And when we square the minus sign, that goes away, so this is just 1 plus tangent of theta squared, which is 1 plus tangent squared of theta, which is secant squared of theta, which is exactly what we wanted to do. Okay. Be very careful, by the way, when you write this, you do not want to write, tangent of theta squared is not equal to tangent of theta squared. Okay, when you write this, it's assumed that you're squaring the angle theta. Okay, so you be careful. You be a little liberal with your parentheses or your brackets. Okay, let's look at this next on number 3. Tangent of theta, cotangent of theta minus cosine squared theta equals sine squared theta. All right, so let's do this. We'll start with the left-hand side again. Okay. Now, tangent and cotangent are reciprocals of each other, so we know this should be equal to 1. And if you're not sure, we can just include this step. Okay, this is 1 over tangent theta. So this will be 1 minus cosine squared of theta. Okay. And then this is equal to sine, because the fundamental identity says sine squared of theta plus cosine squared of theta equals 1. So you could subtract cosine squared from both sides. And you get that this will be equal to sine squared of theta. Okay, which is exactly what we wanted to prove. All right. you can go directly from here to here. This is everyone knows about this, so you don't necessarily have to prove this. Okay, let's look at number 4. Cosecant plus cotangent times cosecant minus cotangent. Okay, so we'll start on the left-hand side again. If you were to multiply this out, foil through foil, first, outer, inner, last, you see the middle terms cancel out because you get cotangent, cosecant minus cotangent, cosecant. So what we get is just cosecant of theta squared minus cotangent of theta squared. Okay. All right. And so what is this? This, of course, let's maybe write this in the usual way. Okay. And then cosecant squared, remember the cosecant squared is 1 plus cotangent squared by the fundamental identity. Okay. And then you can see that these cancel and we get 1. Okay. Which is what we wanted to get. All right. So these were a few of the easier ones. I'll start another video where we do the next 2 pages of this, and they'll be a little more interesting. So I'll see you then.